Hello class, today I'm going to be teaching you about scientific notation and significant figures. So for number one, first we want to know is what is scientific notation used for? So there's a lot of problems in chemistry that have really big numbers, kind of like Avogadro's number, which is 6.022 times 10 to the 23rd power. And these numbers, they're either extremely large or they're extremely small, like 0.0003 liters. And an easier way to express these extremely large numbers and these extremely small numbers is by putting them in decimal form. So that is what scientific notation is used for. It's used to express extremely large and small numbers in decimal form. So the good thing is this number is already expressed in scientific notation. However, this one isn't. So for this one, we're going to find it by seeing how many decimal places it moves back to. 1, 2, 3, 4, 5. There you go. So this would be 3 times 10 to the negative 5 power liters. And that's scientific notation for you. So next we're going to be learning about significant figures. So for number 2, the question is, what is the purpose of using significant figures when dealing with measured numbers? So for measured numbers all have a different level of precision. Is it either between different types of balances or different types of rulers or other measuring tools? They all have different levels of precision. So the purpose of using sig figs in these measured numbers is that they identify the level of precision. Of course, in measuring things, 8 centimeters is going to be less precise than 8.00 centimeters. So your purpose for using significant figures in measured numbers is that significant figures determine the preciseness of a number or a measurement. Last, we're going to be learning about significant figures and calculations. Multiplying and dividing go hand in hand, and also adding and subtracting go hand in hand. So let's do multiplying and dividing first. So for multiplying numbers, the answer is reported with the same number of significant figures as the value with the least number of significant figures. So for example, if you have a calculation like 6.4 times 2.00, this one has 2 sig figs and this one has 3 sig figs. So your final answer is going to be 2 sig figs because your value is with the least number of sig figs, as you can see right here. And next, for adding and subtracting, the answer is reported with the same number of decimal places as the value with the least number of decimal places. So for example, if you have 4.65 plus 3.278, this one is 2 decimal places to the right, and this number is 3 decimal places to the right. So we're getting the value with the least number of decimal places. So of course we're going to be using this number. So our final answer is going to have 2 decimal places. And for your final answers for the multiplying and dividing, it's going to be 12.8 And since we're using 2 sig figs with the least number of sig figs, it's actually going to be turned into 13. And for the adding and subtracting problem, you're given 7.928. That's your answer for this problem. And since we're rounding to 2 decimal places, since it's the least number of decimal places, instead we're given 7.9. Your final answers.